These are the first 5 problems for Algebra A's Test 4 for Quarter 2. And it's going to be mainly a test similar to what you've done the last 2 tests, where we're solving systems of equations and then also writing some equations given points in the slope or just given a series of points. So let's take a look at the first problem that you'll end up seeing. It's solved by graphing. And so the equations will be in slope-intercept form, just like they are here. And you just take the y-intercept and start with graphing a point. So we'll take the y-intercept, which is positive 2, and we'll plot that point. So we go up 2 spaces on the graph and put the dot there, and then use the slope. Well, here the slope is -1, so we could treat that as a fraction as -1 over 1. So typically we'd go down and then to the right. And you could do that a series of times and get lots of points. But the points may not end up crossing here. The lines may not cross in this region. So we should also go the other way, which would be a +1 over -1. So that tells us to go up and then to the left. And so I'll go up 1 space, left 1 space, and I can continue doing that until I run out of room. And so now we'll take a look at the next line, and it has a y-intercept of -4. So I'll start at my y-intercept down 4 spaces from the origin and put the dot there and use the slope. Here the slope is 1, because there's no number out in front of x, so we treat it as a fraction, or just treat it as 1 and write that as a fraction of 1 over 1. Well, that tells me to go up and to the right. And it looks as though this is going to get me to that line, so I'll continue until I cross, and there it is. That's where they end up crossing. And so don't just leave it like this. Make sure you tell me what that point is. It's 3 spaces to the right, so +3, and then 1 space down, so -1. So remember, it goes x and then y. And there's our answer. Well, here's another type of system, and this one just says what is the solution. So they don't ask us a specific method to solve, but this is a good one for substitution. So whenever x or y is equal to something, so we're going to use substitution when we have x equals something, like we have here, like 2y minus 4, or when y equals some expression, so whatever that expression is. And here we've got x equaling 2y minus 4. So we're going to take that term and put it in place of x in the equation below. So we'll go ahead and rewrite our second equation, but in place of x, let's rewrite 2y minus 4. So 2y minus 4 plus 8y all equals 16. So from that point, we could start doing some opposite operations and also collecting some terms. So I'm going to add 4 to both sides first, and then I'll go ahead and collect these 2 terms. And so when I do that, I end up with a 10y equals 20. So a lot of people made a mistake on this problem earlier in the term where we either subtracted the terms or just didn't do the opposite operation right. So remember, opposite operations when you go from one side to the other. So we'll go ahead and divide by 10, and when I do that, I end up with y equals 2. So that's my y-intercept. Now to find x, you just substitute back in. So let's put that 2 back in for this y and rewrite our equation. And so what we've got is x equals 2y, but in place of y, again, we're putting this 2, and then a minus 4. So x equals 4 minus 4, which is 0. So there's the point. 0, 2. That's the y value right there, 0, 2. Well, here's another one where we're just solving. It doesn't say which method, so again, I would use substitution because the variable x equals something. When y equals something or just x equals something, use that substitution method. Take that y minus 4, let's put it in for x, right down below. So we'll rewrite what we've got, and when we do that, we rewrite 3x, but in place of x, let's write y minus 4. And minus 2y equals -7. So in this problem, there's a little bit more work because we have to distribute that 3 over that subtraction. And so once we do that, we now have 3y minus 12 minus 2y equals negative 7. So from this point, just like the last, we've got an opposite operation. So that's a minus 12, so I'm going to end up having to add 12. I can also collect these two terms because they have the same variable, raised to the same power. Now look at the signs in front. One's negative, one's positive, so we end up having to subtract. Well, the nice thing about this one is we're left with y. 3 minus 2 equals 1y. And this equals, here I have to subtract because they're opposite in sign, I get positive 5. So there it is, y equals 5. Let's take that value and substitute it back into this top equation, solve for x. So x equals 5 minus 4, which is 1. So there it is, our answer, 1, 5. And we've got it. Well, two more problems. These problems, again, they just say to solve, so you could use any method, but it's easier just to use the elimination method here because we've got x's, y's, equal signs, constants all in line. So I'm going to go ahead and take this equation and multiply it by 3. And the reason is that I can make it a negative 3y then. And so I'll go ahead and rewrite my equations. And my new equation here will become 15x minus 3y equals 39. So the mistakes I'm seeing when people are doing this is not multiplying every number. Sometimes they'll multiply 2, sometimes just 1, sometimes, well, if they do it right, they'll multiply all numbers. And then also watch the signs. So only one negative here. Let's just go ahead and rewrite this one down below. So we got 2x, a positive 3y, and this all equals 12. So when I add this stuff together, I get 17x. These terms canceled out, and this all equals, you add this stuff together, you get 51. Well, if you didn't know it, 17 goes into 51. And if you think about it, 7 times 3 makes 21. That ends in a 1. So my guess would be that x is going to end up equaling 3, and that is correct. X does end up being 3. So we take that 3, and we substitute. Now make sure you put in for x. I'll just put it in this one right here. So we'll rewrite it, 2x, but in place of x, we put 3. Plus 3y equals 12. So do some opposite operations and multiply. So this will end up making 6 plus 3y equals 12. So we'll do the opposite operation there, which is subtract the 6. And that leaves us with the 3y equaling 6. And then the one step of dividing by 3, and we'll get our answer. So there it is. Y will end up equaling 2. So we've got our answer of 3, 2. That's the ordered pair that represents where the two lines cross. Well, one more problem here, and this one involves, again, elimination, and the reason would be because if you look at the equations, we got x, y, equal signs, constants all in line. So we got a choice. Do we want to get rid of the x's or the y's? I'm going to choose the x's. Multiplying by 5 is smaller than multiplying by 7. So I'm going to multiply this one by 3, this one by negative 5. Because I needed one to be negative and one to be positive. And I'm going to be canceling out the x's. So again, make sure you multiply every number in those two equations by the value on the outside of the parenthesis. So we end up with a 15x plus 6y equals negative 3. Down below, got a negative 15x, a negative 35y, and this all equals negative 55. So we're able to add these together because they are the x's are opposite in sign, they cancel out. So if you ever add things together and they don't cancel, you're doing something wrong. So make sure you're able always to cancel something. In this case, x's are gone. Negative 29 is what we get. We had to subtract because they're opposite in sign. This all equals negative 58. I had to add because they are the same sign. Now, when I think about it, okay, I'm probably not going to end up with a fraction for this test, so I bet you 2 is the number. How many times 29 goes into 58? And that's the case. You see, 2 times 9 makes 18, and this one ends in an 8, so it's another good guess. And it does end up working out. Positive 2 because the two negatives cancel. Take that 2, let's put it back in for y. Let's do that top equation there. So 5x plus 2y, but in place of y we're putting 2, equals negative 1. So we do some work there. 5x plus 4 equals negative 1, and now we'll do some opposite operations. So we'll go ahead and subtract that 4 from all sides. Remember, the same sign there, so you end up having to add those numbers. And so we end up still with that 5x equals negative 5. So you can divide by 5, and you get your answer there. So x is negative 1. So negative 1 comma 2 is the point where the two lines cross. That is our answer. So those are the first 5 problems on this week's test. We got the last 4 problems on part 2.